Today's topic is balancing chemical equations for beginners, and I'll be showing you the basic technique to get started balancing reactions. First, we take an inventory of the atoms. We're going to count how many of each atom are on each side of the equation. Then we're going to change the coefficients that go in front of the chemical compounds until we have an equal number of each type of atom on both sides of the equation. We don't want to change subscripts. And the last step is to simplify the coefficients if necessary. We don't want to find just any combination of numbers that are going to balance the equation. We want to find the lowest ratio of numbers to use as our coefficients. So let's get started. So here we have an unbalanced or a skeleton equation. The first step is to make an inventory. I like to start by drawing a vertical line where the yields arrow is. And that just helps me keep track of what should be on the reactant side on the left and what should be on the product side on the right. It eliminates me making some careless errors. And looking from left to right, the first element we come to is nitrogen. So we're going to write down N for nitrogen. And because it has no coefficient and no subscript, it's understood that there's only one. We're going to write down I, and it has a subscript of 3, so we're going to list that in our inventory as well. Now we're going to go over to the product side, and it's helpful to keep the elements in the same order in your inventory on both sides of the reaction. It makes it easier to compare the number of atoms on both sides and eliminates some opportunities for careless errors. Now the nitrogen on the product side has a subscript of 2, so there are 2 of them, and the iodine also has a subscript of 2. So now if we take a look at our inventory, we can see that neither the nitrogen nor the iodine have the same number of atoms. So I'm going to decide to start with the nitrogen. And I can see that on the product side there are 2 nitrogen, and on the reactant side there's only 1. I need to get 2 nitrogen, which means I really need 2 of the Ni3 molecules. And the only way to get 2 of those is to change the coefficient in front of the molecule. I'm going to put a coefficient of 2. So now I have 2 nitrogen, and I want to adjust my inventory. I'm going to cross off the 1, and I'm going to change it to a 2. Now I also changed the number of iodine because iodine is in that compound, so I'm going to take the coefficient of 2, multiply it by iodine's subscript of 3, 2 times 3 gives me 6 iodine. So looking at the reactant side, I have 6 iodine, and there's only 2 on the product side. I'm going to need to figure out what am I going to multiply by that subscript of 2 to end with 6 iodine. Well, I'd multiply by 3. So 3 times 2 is going to give me 6 iodine. I'm going to adjust my inventory. Now as we look across from left to right, we see that there are 2 nitrogen on both sides of the equation, and there are 6 iodine on both sides of the equation. So we have balanced this equation successfully. Here's another example. We're going to start by making our inventory. When we look at the aluminum, it has no coefficients, no subscripts, so there's understood to be 1 aluminum on the reactant side. The fluorine on the reactant side has a subscript of 2, so there are 2 fluorine. Going over to the product side, there's a subscript after the F, and that subscript only applies to the element directly in front of it, which would be the fluorine. The aluminum doesn't have a subscript, so again, the aluminum is understood to be 1, the fluorine is a 3. So the aluminum appear to be balanced already, but the fluorine are not. We have 2 on one side and 3 on the other. So we want to find the smallest number that both 2 and 3 will go into, and that's going to be 6. So since we already have 2 fluorine on the reactant side, we would multiply that by 3 to have that equal 6. So we're going to put a coefficient of 3 in front of the fluorine, and before we go any further, we want to make sure we adjust our inventory so we don't lose track of what we've already done. Then going over to the product side, there are 3 fluorine already. We would want to multiply that by 2 in order to have 6 fluorine. And it's important that we put the 2 in front of the aluminum. The coefficient has to go in front of the chemical formula for a compound. It can't go in the middle. So we're going to fix our inventory for fluorine and change it to 6. But we also need to adjust our inventory for the aluminum, because that coefficient of 2 changed not only the fluorine, it changed the aluminum as well. And now there's going to be 2. And we're going to need to go back to the reactant side and put a coefficient of 2 in front of the aluminum, change our inventory, and now when we take a look, we can see that when we look at the aluminum, both of them are equal to 2, and both of the fluorine are equal to 6. And then if we look at our coefficients, there are 2, they are 2, 3, and 2. And so we're not going to be able to simplify those. There's not a number that we can divide by and end up with a smaller whole number. So we're going to leave the coefficients as they are, and our reaction is balanced. So let's see what happens in this next chemical equation when we have parentheses in one of the compounds. We're still going to make our inventory same as before. The first element we come to is aluminum, and aluminum has no coefficient, no subscript, so it's understood to be 1. And then we see that the oxygen is inside the parentheses, and there's a subscript of 3 outside, which means everything inside has to be multiplied by 3. So the number of oxygen on the reactant side is 3. Now the hydrogen is also in the parentheses and needs to be multiplied by 3. But if we look carefully on the reactant side, we'll see that there's an H in the other compound as well, and we need to add them together in our inventory for the hydrogen. So there are 3 hydrogen in the parentheses plus 1 hydrogen in the HCl. So altogether on the reactant side, we have 4 hydrogen. And then there's also chlorine on the reactant side, and it has no subscript, so that's going to be 1. Now we'll go to the product side, and we want to list our elements in our inventory in the same order that they are on the left side. And the aluminum has no subscript, so it's a 1. The chlorine has a subscript of 3. The hydrogen is 2, and the oxygen in the water is going to be a 1. So we can see that 3 of the elements are not balanced. And because the hydrogen shows up in 2 different compounds on the reactant side, we don't want to start balancing the hydrogen first. If we can balance out the oxygen and the chlorine, the hydrogen should fall right into place. So I'm going to start with the chlorine. And I can see that there are 3 chlorine on the product side. To get 3 chlorine on the reactant side, I'm going to put a 3 in front of the HCl. And then I'm going to immediately change my inventory. But that coefficient of 3 also changed the hydrogen. So now in the HCl, there's not 1 hydrogen, and there will be 3. And we already had 3 hydrogen in the other compound, so 3 plus 3 is going to give us 6 hydrogen. Now to get 3 oxygen on the product side, we'd have to put a 3 coefficient in front of the H2O, which changes the oxygen to 3, but it also changes the hydrogen to 6. So now as we carefully compare the left and right hand side of our inventory, we see that every single element is balanced on both sides. Let's try one more problem. This time we'll do a combustion reaction. Same procedure. We're going to make our inventory. So we have 2 carbon on the reactant side, there are 6 hydrogen, and there are 2 oxygen. I'm going to make that same order of letters on my inventory on the product side, and I can see that there's 1 carbon, there are 2 hydrogen, and here we have the oxygen split between 2 molecules. There's 2 oxygen in the carbon dioxide, and there's 1 oxygen in the water. So altogether on this product side, we have 3 oxygen. All right, so nothing is balanced. We could start with any element, but again, since oxygen is split between 2 compounds on the product side, it's not wise to start with oxygen. We should start with one of the others. So let's start with carbon. There's 2 carbon on the reactant side, so we need to put 2 on the product side. We do that by changing the coefficient. We're going to put a coefficient of 2 in front of the CO2 and then immediately adjust our inventory. We change the number of carbon. We also change the number of oxygen. We're going to multiply the coefficient by the subscript for the oxygen, and that's going to be 4. We're going to add those 4 to the 1 oxygen in the water on the product side, and the oxygen now has 5. And now we need to look at the hydrogen. There's 6 hydrogen on the reactant side and only 2 on the product side. So we could multiply by 3. 3 times 2 will give us 6 hydrogen. And now that changed the number of oxygen as well. So we had the 4 oxygen in the CO2, and now we have 3 oxygen in the water. We're going to add those up, and we get a total of 7 oxygen on the product side. So when I go over and look at the reactant side, because the oxygen has a subscript of 2, No matter what coefficient we put in front of it, it's always going to be an even number. So we can only have an even number of oxygen on the reactant side. So the only way to get an even number of oxygen with that water molecule is to put an even coefficient in front of it. But we want to make sure we pick an even coefficient that is a multiple of 6, since we have 6 hydrogen on the reactant side already. So let's go ahead and change that 3 coefficient to a 6. And that's going to change the number of hydrogen now on the product side to 12, and it's going to change the number of oxygen as well. We're going to have 6 oxygen from the water, not 3, and we're going to need to add that to 4 oxygen that the carbon dioxide is providing, and now that gives us a total number of oxygen on the product side of 10. We need to go back and change the hydrogen now on the reactant side as well. On the reactant side, we only have 6 hydrogen. We need to double it. So we're going to put a coefficient of 2 in front of the compound that contains hydrogen. Now that changes the carbon to 4. So we're going to change our inventory there. And it's brought the hydrogen on the reactant side up to 12. So now when we look at it, we see that the carbons are no longer in balance. We originally put a 2 coefficient for the CO2. Now we see that's not going to work. So we just go in and change it. We're going to take out the 2 and we're going to change it to a 4 so that we can get 4 carbon on the product side. But that also changed the number of oxygen again. So 4 times 2 is going to give us 8 oxygen from the carbon dioxide. And we need to add the 6 oxygen from the water to that. Now we have a total number of oxygen of 14. So now I see, if I go back to the reactant side one more time, that there's only 2 oxygen. I need to make it 14. So I'm going to multiply it by 7. I'm going to put a coefficient of 7 with the oxygen. And now the reaction is balanced. Phew. Sometimes the first coefficient you put in, you're going to realize later isn't going to work. And we just take that coefficient out and put a new one in, and we just keep working on it until it finally becomes balanced. With practice, you find that balancing equations gets easier and easier, so keep practicing. So thanks so much for joining me, and I'll see you soon.